Okay, so this is where we were in our last video. What we did was to find the critical points of this function x squared plus y as the function, and we give the constraint x squared plus y squared equal 4. So here, the steps we took, we have the gradient function, the gradient vector of the function, it should be upside down. The gradient vector of the function is equal to the Lagrange multiplier times the gradient vector of the constraint, right? Then, after we find these, which would be delta f by delta xi plus delta f by delta yj is equal to lambda times delta g by delta xi plus delta g by delta yj. After that, we equate I and j, not just I and j, the thing there, the coefficients. So delta f by delta x is equal to lambda delta g by delta x. Also, delta f by delta y is equal to lambda delta g by delta y. And then we have the constraint, which is g of x, y. We have 3 simultaneous equations, and we solve for x and y. So that's basically what we did, all right? Now we found that the gradient vector are these points, all right? Now, what you can do to find out whether it's maximum or minimum, let's find out what the value of the function is at one point. The function is x squared plus y. So f of x, y is equal to x squared plus y. Now, we have a point here at square root of 15 over 2 half. Square root of 15 over 2 half. Now, the square root of 15 over 2 half, and we have negative square root of 15 over 2 half. Now let us find out exactly what these things are, and then we come back to this. Let's write them in the form of decimal form, right? We could work them out in fraction form for now, but for what we're going to do later on is find a number close to it, but to the left and then to the right, and see what happens. Now, at square root of 15 over 2 half, f is equal to, well, f of x, y is exactly equal to, alright, this would be the exact value. So let's work it out like this. X squared, which would be 15 over 4 plus half, is equal to, alright, let me just use my calculator off the air. It's a fraction calculator, 15 over, I don't need to do that, just work it on the screen here. 15 over 4 plus half is the same as 15 over 4 plus common denominators, double tap on the bottom, is 17 over 4. Now, what is 17 over 4? 1 minute, let me convert it. 4.25. F is 4.25. Alright? Now, you see this square root of 15 over 2. It is 1.936. We could have worked it this way, as I said before, 1.936, comma 0.5. Suppose that's what we did. Right, let's work it out using this calculator here that we have. 1.936, 0.5. Alright, this is our calculator. 1.936 multiplied by 0.5 equal, oh, what am I doing? 1.936 squared, right, equal plus 0.5 equal, alright, we'll get our 4.25, just as we have here. Now, let us go in one direction, in any direction. If we are at the top, and we move, whether we move east, west, north, or south, we'll be going down. So we'll be at a maximum point. And if we're at the top of the hill and move, we have to be going down. If we're at the bottom of the valley, any movement will take us up. Now let's see if we're going up or down. 1.936. Let's use 1.9 and 0.4. 1.9 squared plus 0.4 equal, we go down, right? Let's use a higher number. 2 squared plus 0.6 equal, well, in this case, we go up a bit, right? Now, if we go to the left, we go down. Now, let's make the x alone move. 2 squared plus 0.5. We go up a bit. And then, well, could this critical point be a point of inflection? It seems so. If we go to the left, we go down. If we go to the right, we go up. So the gradient of this is 0. So it seems like some point of inflection in this case. Right? If we move a bit, say 2.1 squared plus 0.6. Right, seem like some point of inflection there. The point of inflection, remember, you go up, then you go level, and then you go up again. Alright, and then if we try the negative, well, it would make a difference. Right, so it seems as if there is some point where we go up, we go level, and then we go up again. Right, so it seems to be a point of inflection there. A critical point. Alright, anyway, we're not asked to find the nature, but you're asked to find the location, and we found what the location is. Now, finally, let's go over the steps again. You follow these steps in all of them. You write the formula, gradient function of gradient vector of the function is equal to the Lagrange multiplier times the gradient function of the constraint, or the gradient vector of the constraint. Now, the gradient vector of the main function is delta f by delta xi plus delta f by delta yj. I and j are the directions. That's equal to the Lagrange multiplier times delta g by delta x in the I direction plus delta g by delta y in the j direction. Alright? Now, the coefficients of I and j, you equate them. So you get two equations. This in front of the I is equal to this in front of the I. But you would expand the bracket and have the lambda multiply each, right? This in front before the j equal this in before the j. So delta f by delta x is equal to lambda delta g by delta x, and delta f by delta y is equal to lambda delta g by delta y. Then you have the constraint itself, because these two vectors, they start at the same point, right? But that point must coincide with the boundary of the constraint. So you put the constraints there. Then you do your arithmetic and you solve for x and y. So you find the location of the critical points. Alright, so that's it for now. I'll see you in the next video.